Hi everyone. In this video I'm going to show you how I install the second auxiliary battery in my Pajero NT, as well as a 3 kilowatt inverter. If adding a second auxiliary battery interests you, I recommend that you check out my earlier video from 2021, showing how I installed my original auxiliary battery and DC-DC charger, which are still all working perfectly after a number of extended camping trips. The link to that video is shown at the bottom of the screen. The main reason for this upgrade was that I wanted to be able to run one or more mains powered devices up to the standard power limit for a single 240 volt house appliance. A little while ago I happened to see the Renogy 3000 watt pure sine wave inverter on sale for less than the price of the 2000 watt version, so I snapped it up. I am not in any way affiliated with Renogy. However, it was a great price at the time, and the brand has a good reputation based on my online research. The Renogy inverter is capable of up to 3 kilowatts, although in practice I only wanted to be able to run a single appliance occasionally up to about 2.4 kilowatts, which is the same as running a single 10 amp appliance on 240 volt AC mains. Lithium batteries have the advantage that they can deliver their maximum current continuously at their rated capacity. So a 100 amp hour rated lithium battery can in fact deliver 100 amps continuously. My original auxiliary battery capacity is 100 amp hours, so I needed to parallel using the same battery to double the capacity to 200 amp hours. When paralleling batteries, it is strongly recommended that both batteries are the same brand, capacity and age, so that the load is shared equally across both batteries. There was of course nothing I could do about the fact that the original battery is 2 years old. However, it hasn't been much used and it has never been discharged below around 50%. So in an electrical sense, it won't have aged much. It's worth noting that the new battery, while being the identical make and model as the original, is no longer supplied with an internal Bluetooth monitor. So I purchased the external Victron monitor as offered by the supplier. The good news about this upgrade is that all of the wiring for this work is done at the rear of the vehicle using the existing DC-DC charger, fusing and power cables that run to the engine bay. The other good news is that, fortunately, there is enough space under the Pajero's cargo area to house both batteries side by side, with the addition of an extra battery tray and battery holder, using the same models as in the original install. I struggled to decide the best location for the inverter, which, at 3 kilowatts, is quite large. I reckon there is just enough room around the inverter for cooling, although I will need to monitor the temperature under heavy loads if used for extended periods. In any case, the maximum load I'll ever place on the inverter is 2.4 kilowatts, limited by the batteries themselves, which is significantly below its rated capacity of 3 kilowatts, and I only expect to run the inverter occasionally and for relatively short periods, so I'm not expecting any issues. To begin with, I drilled 4 holes through the floor pan to mount the battery holder at the right-hand side of the existing battery. Be careful to allow enough room for the battery holder clamp on the left-hand side to not interfere with the existing clamp, and so that the 2 new holes nearest the existing battery avoid the support structure underneath the car. The mounting bolts I used are the same as the ones used for the original battery. And as for the original battery, I ground off about 1 millimeter from the heads to ensure that the battery wouldn't rub on them after installation. After drilling the holes for the 8 millimeter steel bolts, I installed the battery carrier and applied foam to the base, the same as I had done for the first auxiliary battery. I also cut the bolts so that they wouldn't stick out too far under the car. Though not strictly necessary, after mounting the battery tray and tightening the bolts, I etch primed underneath and sprayed black enamel paint for rust prevention. After installing the battery, I cut the battery mounting clamps to closely match the lengths of the first battery clamps. You need to do this so that they don't rub against the cargo cover when it's replaced later after the installation. And instead of using the supplied wing nuts that came with the clamp kit, I instead used nylon lock nuts to tighten down the battery clamps. The reason is that the ears on the wing nuts stick up and can rub on the plastic cover, so using nuts ensures this won't happen. It's important that before connecting the batteries in parallel, make sure that both batteries are fully charged so that their voltages are a close match. And with the battery physically secured, it was just a matter of splitting the various lugs to the connected devices across both batteries so that no one terminal had all of the lugs, which would have made the whole thing a bit unwieldy. I've had to replace the supplied battery terminal bolts as these were just a bit short for the number of lugs needed. For these I used the same 8mm bolts as I used for mounting the battery trays and cut these to the required lengths as needed. The devices which connect to the batteries are a DC-DC charger, UHF CB radio, USB charging port, the Victron Smart Battery Sense, and a 50 amp lead to an Anderson plug that runs, or typically runs, my 12-volt fridge. Because the inverter can draw up to around 200 amps, the connections to it require special attention. For this, I connected the positive of the inverter input to the positive post of one battery and the negative lead of the negative terminal to the other battery. This ensures the load presented to each battery is balanced and to compensate for any resistance in the cables that parallel the two batteries. Except for the inverter itself, running a high-load appliance, all of my other devices present relatively small loads, so this is not important for them. Because of the potentially very high currents running into the inverter, I purchased 2 sets of booster cables from Kmart, which were quite cheap, each set of which is rated at 400 amps, although in practice that rating would only apply for a short period, such as when you're jump starting an engine. I cut the battery clamps off one end of each cable and crimped and soldered lugs to the bare wire ends. Heat shrink was used to cover the exposed wire and for some strain relief. I paralleled the cables between the batteries and the inverter, which should provide more than enough current capacity for continuous use. 2 fuses were required for this project to go in line between the batteries and the inverter inputs. These are rated at 125 amps each, 1 fuse per positive cable. Since the maximum continuous load into the inverter will be around 100 amps per cable, for a total of 200 amps, the fuses should not blow. These lithium batteries are rated at up to 200 amps each for up to 5 seconds, which is enough to blow the fuses in an overload situation. These are the lugs I used and which I purchased on eBay. These match both the fittings on the inverter input terminals and the battery terminals. Renogy supply a lightweight panel mount switch and flat cable with the inverter to remotely turn the inverter on and off. This is quite large and was obviously intended to be mounted on a wall panel as in a van. For my application, I cut a rectangular hole in a plastic hobbyist box, attached the panel with suitable screws to the box and mounted this to my cargo barrier with long self-tapping screws, which pass through the spaces in the cargo barrier mesh. It's quite sturdy, very neat, and is out of the way while still being easy to access. The supplied flat cable is routed and cable tied to the edge of the cargo barrier and routes to the underfloor inverter via the opening at the left-hand side of the cargo cover as per all the other device wiring. Here's the before view showing the original auxiliary battery. And here's the view after completing the installation. The red and black cables that parallel connect the 2 batteries were made from cables supplied with the inverter, but I have shortened these and crimped new lugs to one end of each of the red and black cables. Note that I have also placed a couple of pieces of packing foam between the batteries to help absorb vibration, and I taped anti-slip mesh to the side of the inverter to prevent it rattling, as the inverter is simply sitting loose in the compartment. Note that I also used cable ties throughout to ensure cables are neat and that things don't work loose. You can also see the Bluetooth monitor, that is the small blue box, mounted to the side of the new battery with the supplied self-adhesive tape. And that's it. I hope you found this useful. Please let me know in the comments section. And also let me know if you'd like me to add any links to the suppliers that I've used. Thanks for watching.